Good morning. Today, let's complete the remaining questions of exercise 8.2 of chapter Quadrilaterals. In our previous lecture, we have solved till question number 2 of exercise 8.2. So, next question, that is question number 3. ABCD is a rectangle and P, Q, R and S are midpoints of the sides AB, BC, CD and DA respectively. Show that the quadrilateral PQRS is a rhombus. Now for solution, first we write the given from the question itself. That is, a rectangle ABCD is given in which PQRS are midpoints of sides AB, BC, CD and DA respectively. Yes, you can see in the figure. Yes, these four P, Q, R and S are midpoints. We also joined PQ, QR, RS and SP. Now, to prove PQRS is a rhombus, for that we need a construction, so we join AC. Yes. Now, for proof, in triangle ABC, this is our triangle ABC. In triangle ABC, P is the midpoint of AB and Q is the midpoint of BC. Therefore, PQ is parallel to AC and PQ equal to half AC by midpoint theorem. Let it be number 1. Similarly, in triangle ADC, now this is triangle ADC, S is the midpoint of AD and R is the midpoint of CD. Therefore, SR is parallel to AC and SR equal to half AC. This is also by midpoint theorem. Let it be number 2. From 1 and 2, we get PQ parallel to SR and PQ equal to SR. Let it be number 3. We have seen that SPQ is parallel to AC and SR is also parallel to AC. So we will get PQ parallel to SR because lines parallel to the same lines are parallel to each other. And SPQ equal to half AC and SR equal to half AC. So we will get PQ equal to SR. Now, in quadrilateral PQRS, as we have joined the midpoints of the rectangle, we get a quadrilateral PQRS. Its one pair of opposite sides PQ and SR is parallel and equal. Now, from 3 we can see that PQ is parallel to SR and PQ equal to SR. Therefore, PQRS is a parallelogram. Now, AD equal to BC. Why D is equal to BC? Because it is a rectangle and in rectangle opposite sides are equal. Therefore, half AD equal to half BC. Yes, we multiply both the sides by half, so we will get half AD equal to half BC. Implies that now half of AD is AS and half of BC we take as BQ. Yes, you can see this. Yes, this part we are taking as half AS and this BQ, half of BC. So, in triangle APS and triangle BPQ, yes, you can see APS, this small triangle APS, and in triangle BPQ, this another small triangle. Let's see the equality. AP equal to BP. Why both are equal? Because P is the midpoint of AB. AS equal to BQ. We have proved above. And angle PAS equal to angle PBQ. Since both are 90 degree, as all the angles of rectangle are 90 degree. Therefore, triangle APS is congruent to triangle BPQ by SAS congruence rule. Therefore, PS equal to PQ. Let it be number 5. Why PS is equal to PQ? This is the CPCT. From 3 and 4 we have PQRS is a rhombus. Yes, our 3 is what? Here you can see 3 is PQ is parallel to SR and PQ equal to SR. This we are getting PQ equal to SR. That is our 3. And here in CPCT we got PS equal to PQ. As all the sides are equal of the given quadrilateral, therefore PQRS is a rhombus. Hence proved. Next, question number 4. ABCD is a trapezium in which AB parallel to DC, BD is a diagonal and E is the midpoint of AD. A line is drawn through E parallel to AB intersecting BC at F. See the figure? Show that F is the midpoint of BC. Yes? So for solution, first let's write the given. What is given? ABCD is a trapezium in which AB is parallel to DC and BD is a diagonal and E is the midpoint of AD. This is given. 3 things are given, that E is the midpoint of AD. These 2 sides are parallel to each other and BD is a diagonal. These 3 things are given. Now we have to prove that F is the midpoint of side BC. For proof, let BD intersect EF at G. Now where the diagonal BD is intersecting the line segment EF, let it be G. Name, we have given here the name G, here you can see. So in triangle BAD, yes, this is our triangle BAD. In triangle BAD, we will know that E is the midpoint of AD and also EG. This line is parallel to AB because DC is parallel to AB. Thus, G is the midpoint of triangle BAD by converse of midpoint theorem. Now in another triangle BDC, let us see the another triangle BDC. Here you can see the triangle BDC. Again, as we have proved above that G is the midpoint of BD. And also GF parallel to AB parallel to GC. Therefore, we will get F. This F is the midpoint of BC by converse of midpoint theorem. Hence proved. Next, question number 5. In a parallelogram ABCD, E and F are the midpoints of sides AB and CD respectively. See figure, show that the line segments AF and EC trisect the diagonal BD. Yes, for solution, it is given. Let's write the given first from the question, that it is given in a parallelogram ABCD, E and F are the midpoints of sides AB and DC. Yes, you can see this is also midpoint and this is also midpoint of sides AB and CD respectively. Now we have to prove, important proof is important. What we have to prove? That DP equal to PQ equal to QB. That is the diagonal BD. This is the diagonal BD. It is divided into 3 parts. So it is called trisect. Trisect means we have to prove this DP equal to PQ equal to QB. These 3 parts are equal of line segment BD. This we have to prove. So for proof, since E and F are midpoints of AB and DC respectively, we get AE equal to half BC and CF equal to half DC. Yes, we know that E is the midpoint of AB. So AE, this is half of BC. Similarly, as F is the midpoint of CD, we will get CF is equal to half of DC. Let it be number 1. But AB equal to DC and AB parallel to DC. Why this AB is parallel to DC and AB equal to DC? Because they are opposite sides of a parallelogram. It is given that ABCD is a parallelogram, and in parallelogram opposite sides are equal and parallel. Therefore, we get AE equal to CF and AE parallel to CF. So, here as we know that opposite sides are parallel and equal, so we will get AE equal to CF and AE is parallel to CF. Implies that AECF is a parallelogram. So we will get this as parallelogram AECF. This is our parallelogram. Why? Because we have proved that AE is parallel to CF and equal to CF. So we get AECF as parallelogram. Now in triangle BAP, yes, let us see the triangle BAP. This triangle BAP. E is the midpoint of AB, already it is given. Therefore, EQ is parallel to AP. Yes. Converse of midpoint theorem, we get Q is the midpoint of BP. So, we will get that Q is the midpoint of BP by converse of midpoint theorem. First we have taken what? Triangle BAP. This triangle. Yes, in triangle what it is given? It is given that E is the midpoint of AB, and we know that as AECF is a parallelogram, we will get EQ parallel to BP. So according to the converse of midpoint theorem, we will get that Q is the midpoint of side BP, yeah, PB. Implies that PQ equal to QB. So as Q is the midpoint of BP, we will get PQ equal to these two sides are equal. Let it be number 3. Similarly, in triangle DQC, okay, now another triangle we select, that is triangle DQC. This is our triangle DQC. Again in DQC we know that F is the midpoint of CD and also PF is parallel to QC. So we get P, this P is the midpoint of side PQ. As P is the midpoint of side DQ, we get DP equal to PQ. Let it be number 4. So from 3 and 4 we have DP equal to PQ equal to QB. You can see in 3 it is given PQ and QB are equal, and in 4 it is given DP and PQ are equal. So from 3 and 4 we get DP equal to PQ equal to QB. Or we can write line segments AF and EC trisect the diagonal BD. Hence proved. As BD is divided into 3 equal parts, we say that line segments AF and EC. Yes, you can see the line segments here, AF and EC, they are dividing the diagonal BD in 3 equal parts, that is trisecting the diagonal BD. Hence proved. Next, question number 6. Show that the line segments joining the midpoints of the opposite sides of a quadrilateral bisect each other. Yes. So for solution, first let's write the given. Given ABCD is a quadrilateral in which EG and FH are the line segment joining the midpoints of opposite sides. Yes, it is given that ABCD is a quadrilateral where this line segment EG and line segment FH, they are joining the midpoints of all the 4 sides of the given quadrilateral ABCD. So we have to prove EG and FH bisect each other. For this, first let's do the construction, that is join EF. We will join all the midpoints of the respective sides of the quadrilateral, that is join EF, FG, GH and HE, and also we'll join the diagonal AC. So for proof, in triangle ABC, E and F are midpoints of AB and BC respectively. Yes, let's see in the figure. In triangle ABC, this is triangle ABC. We know that E and F are the midpoints of AB and BC. So we get EF equal to half AC and EF is parallel to AC. Let it be number 1, and this is by midpoint theorem. Similarly, in triangle ADC, yes, another triangle ADC, we know that H is the midpoint of AD and G is the midpoint of CD. So we get HG is equal to half AC and HG parallel to AC. This is also by midpoint theorem, and let it be number 2. Now from 1 and 2 we get, yes, let's see, this is our 1 and this is our 2. So we get SEF is equal to half AC and HG is equal to half AC. Therefore EF equal to HG, and SEF is parallel to AC and HG is parallel to AC. We get EF parallel to HG. Hence EFGH is a parallelogram. So we prove that this EFGH is a parallelogram. Since a quadrilateral is a parallelogram if its one pair of opposite sides is equal and parallel. Now EG and FH are diagonals of the parallelogram EFGH. Now when we talk about the parallelogram EFGH, you can see that EG and FH are the diagonals of the parallelogram. Therefore EG and FH bisect each other, because we know the property of parallelogram, and it is one of the property of parallelogram that by diagonals of parallelogram bisect each other. So we write that EG and FH bisect each other. Why? Because diagonal of a parallelogram bisect each other. This is the property. Hence proved. Next, question number 7. ABC is a triangle right angled at C. A line through the midpoint M of hypotenuse AB and parallel to BC intersects AC at D. Show that number 1, D is the midpoint of AC. Number 2, MD is perpendicular to AC. Number 3, CM equal to half MA equal to half AB. So for solution, first let's write the given. A triangle ABC in which angle C equal to 90 degree and M is the midpoint of AB and BC parallel to DM. Yes, three things is there. Angle C is given as 90 degree. This M is the midpoint of side AB, this side, and third thing is given, BC is parallel to DM. These three things are given. Now to prove, number 1, D is the midpoint of AC. Number 2, DM is perpendicular to BC. Number 3, CM equal to half MA equal to half, CM equal to MA equal to half AB. Now for this we do construction, that is join CM. We will join CM. For proof, in triangle ABC, yes, we know that in triangle ABC it is given that M is the midpoint of AB. Also it is given that BC is parallel to DM. This is given. Therefore we will get that D is the midpoint of AC by converse of midpoint theorem. Next, second proof. Yes, for that, angle ADM, this is your angle ADM equal to angles ACB. These both angles are equal. Why they are equal? Because they make a pair of corresponding angles. As DM is parallel to BC and we take AC as a transversal. So we get angle ADM equal to angle ACB as the pair of corresponding angles. But angle ACB equal to 90 degree, that is given. Therefore, we will get angle ADB equal to 90, ADM equal to 90 degree. Also, we know that angle ADM plus angle CDM, when we add angle ADM and angle CDM, it is 180 degree. Why? Because they make a linear pair. So from that we get angle CDM equal to 90 degree, because we know it is already given that angle ADM is 90 degree. So here we will get 90 degree plus CDM equal to 180 degree. So we get angle CDM equal to 180 degree. Now as both this is also 90 degree, this is also 90 degree, so we get that MD is perpendicular to AC. And the third proof, for third proof, first we SD is the midpoint of line segment AC, we will get AD equal to CD. Now in triangle ADM and in triangle CDM, these two triangles ADM and CDM, yes, we get angle ADM equal to angle CDM. These two angles are equal, both are 90 degree. Next, AD equal to DC and DM equal to DM, common. Therefore, triangle ADM is congruent to triangle CMD by SAS congruence rule. Implies that CM equal to MA. Yes, by CPCT of these two triangles we will get CM equal to AM. Now we know that since M is the midpoint of AB, yes, M is the midpoint of AB, therefore MA equal to half AB. MA will be half of AB. Yes. Now we have proved ahead that already we can see here from number 2, CM and MA are equal. So we write CM equal to MA equal to half AB from 2 and 3. Hence proved. Dear students, please copy all these in your regular CW with figures. And here we complete with the chapter quadrilaterals. Thank you.